Hey, hello students. In this video, we are going to discuss about one important reaction for IIT JEE and NEET examination, that is called Wurtz reaction. So let us discuss it elaborately so that we can understand, we can do every questions coming from this particular reaction, which is called named reaction, right? So what is Wurtz reaction? So Wurtz reaction especially indicates about, so Wurtz reaction is all about the mixing of or the combination of combination of alkyl halide, combination of alkyl halide, in the presence of sodium with dry ether to form the corresponding product, which is called alkane. So from alkyl halide to alkane is called what? Wurtz reaction in the presence of sodium with dry ether. Sir, let us take one example. So let us take the example number 1, where we have to take one thing, that is, which is called CH3Cl. Now what is the name of this compound? This is called methyl chloride. Methyl chloride we have to take in the presence of sodium with dry ether. Sodium with dry ether. The corresponding product will be C2H6, which is called ethane. That means it is very clear that from one carbon we got the two carbons product, which is called, this is double. That's why here we can write 2 moles of CH3Cl, otherwise no need to write, because in a container, if we take the container and if we want to do this particular reaction, obviously we should not write this one as 2 moles, because already there are lots of molecules of CH3Cl will be there. So one CH3 will combine with another CH3 to form C2H6, which is called ethane. So if we take the another example as well, then we can take, for example, I'm taking this one. This is 1, this is 2, and this is 3. Now this is called propyl chloride. Propyl chloride in the presence of same sodium with dry ether. Sodium with dry ether, the corresponding product will obviously like this. So which is 1, 2, 3, 4, 5, 6. Here it is 7, so we have to decrease this. So this is the kind of product we got, which is called hexane. Now which is called what, sir? This is called hexane. So I hope it is clear that if we take the 2 carbon, then we will be getting 4 carbons. If we take 1 carbon, then we will be getting 2 carbon product. If we take 3 carbons, then we will get 6 carbon containing product. So we can say that, so we can say that from here it is very clear that Wurtz reaction, Wurtz reaction is valid or is used, is valid for only symmetrical, this is very important statement, that this is valid for symmetrical alkanes. So this is the conclusion part we got over here, which is called, this is only valid for symmetrical alkanes. Now the question is, if we take any other 2 different type of alkyl halide, then what is the scenario? So let us take that also. So this is example number 3. We have to take this one as example number 3. So let us take CH3Cl, and it is going to combine with another alkyl halide, which is C2H5Cl, and the same way with sodium, dry ether. Let us assume what are the products can be formed. Obviously CH3 will combine with another CH3 so that it will form the corresponding product, which is called C2H6. C2H6. Now this is called ethane. No doubt, very good. Ethane. Now here C2H5, C2H5 will combine with another C2H5 to form again another product, which is called C4H10. Now this is called butane. It is also very clear. Now the question is, this one and this one will also combine. Yes, this will combine and will form the corresponding product, which is C3H, C3H8, C3H8. So these are the combination product. This is called now propane. So we got 3 types of different products, which is ethane, butane, and propane. But the interesting thing is, in the example 1 and 2, the percentage of yield, is very high. But in the case of example 3, the percentage yield is very low or less. That's why the statement we got over here, which is called Wurtz reaction, is valid only for, okay, symmetrical alkanes. Yes, this is for symmetrical alkanes because the percentage yield, or the we can say the amount which will be produced in this particular reaction is more for symmetrical alkanes, not for unsymmetrical or asymmetrical alkanes. That's why Wurtz reaction is valid for symmetrical. Now the point is, what is the mechanism behind it, sir? Obviously, it follows again, which is called free radical mechanism. So it is very clear that it also follows free radical mechanism, because in alkane chapter, maximum all the reactions follow free radical mechanism. Shortcutly, we can say this as FRM. So free radical mechanism. So let us see that as well. Okay. So what is the mechanism behind it? So let us look at it. Okay, mechanism. So first thing first, what will happen? So here we are getting what's up? We are taking sodium, and sodium is a very good metal, electropositive metal. Also, it is an active metal. Okay, this is also an active metal. Right, this is an active metal. So it will obviously convert into Na plus to get octet with releasing some electron, or 1 mole of electron. Now this 1 mole of electron, okay, 1 mole of electron, okay, this is in step number 1. Okay, we got over here, and now let us write step number 2. Okay, in step number 2, what will happen? So this, okay, this electron will combine with, okay, with any substrate we have taken, that is called CH3Cl. Obviously, there is an electronegativity difference between chlorine and carbon. It is delta negative and this is delta positive. So what will happen? This will take up the electrons. Okay, this will take up the electrons and will convert into, okay, will convert into Cl minus. And now this electron, okay, is going to attack on the carbon, so that it will form the corresponding free radical, right? So from here we got the free radical of CH3. Okay, CH3. Now step number 3 followed by, okay, step number 3 is followed by, let us do that, CH3 radical. Okay, in the container there are lots of molecules of CH3 radical will be there, or there are lots of radical of CH3 will be there. So this CH3 radical will combine with another CH3 radical, right? So this is going to combine with another CH3 radical to form the corresponding our desired product, which is called C2H6, or we can write in this way as well. Okay, no issues, we can write in this way, which is CH3, okay, combined with another CH3. Now this free radical made a bond like this. So this is a thing. Okay, this is called now ethane. Okay, and obviously here Cl minus is there and here Na plus is there. So both of these will combine and they will form NaCl as a salt. So this is the corresponding product, and this is what called the mechanism. So it follows free radical mechanism. If we get any kind of questions, then how we have to do, sir? Very simple. Okay, nothing to do. That's simple. We have to take like this. Suppose example we have this one. Okay, Cl is there, and here we are taking Na with dry ether. De means dry ether. So how can we form the product? Nothing to do. Okay, so the main product will be like this. So how it can form? So that in exam time we have to do like this. So this chlorine will be removed from this. Okay, and from here we will be getting like this. So this is the free radical we got over here. Okay, after removing the Cl, this is the kind of scenario, this is the kind of product will be formed, like intermediate form. Okay, now, right? So this will combine with another type of intermediate, same like mirror image or bhai, right? So they will combine with each other to form the corresponding product like this. So in this way we can form. Okay, so this is all about the Wurtz reaction. Okay, in the next video we are going to do the questions from here, which are going to come in the examination, which are important questions as well. So from the Wurtz reaction we will be getting different type of questions. We'll solve in the next class. Okay, I hope this video is useful for you and you got the clarity of Wurtz reaction. If you like my video, then please like, share and subscribe my new channel. It will be helping out a lot. Thank you. We'll meet in the next video. Bye bye.